Again, welcome to Calculus, Mathematics 200. In this lectures, we're going to find the derivative of a function using the sum and difference rules. Also, we are going to find the derivative of sine function, cosine function, and exponential functions. So the sum and difference rules, for example, if we have a function f at x plus g at x, the derivative of it will be derivative of f at x plus derivative of g at x. With the difference, f at x minus g at x is equal to the derivative of f at x minus derivative of g at x. So let's see an example here. Here they say we should find the derivative of a function x cubed minus 4x plus 10. So we are going to find the derivative of x cubed, then derivative of 4x, and derivative of 5. Now we know the derivative of x cubed is the power rule, so the answer will be 3x squared. Derivative of minus 4x is using the constant multiply rule. So we know derivative of x is 1, so it will be 1 times negative 4, so that will give us negative 4. Now derivative of any constant value is 0. So the derivative of x cubed minus 4x plus 5 will give us 3x squared minus 4. Next, we should find the derivative of g at x, which equal to negative x to the power 4 divided by 2 plus 3x cubed minus 2x. So we are going to find the derivative of negative x to the power divided by 2, which will give us negative 4x cubed divided by 2. 4 divided by 2 will give us 2. So it will be negative 2x cubed. We use the power rule. Next, we have derivative of 3s cubed. 3, we leave it. The derivative of s cubed will be 3 times x to the power 3 minus 1. Again, using the constant multiply rule. So we leave the constant 3. We find the derivative using the power rule. S cubed will give us 3s squared. So that will give us 9s squared. Then the derivative of minus 2x will give us 2, because the derivative of x is 1. It will be 1x to the power 1 minus 1. S to the power 0 is 1. So negative 2 times 1 will give us negative 2. So the derivative of negative 4x to the power 4 minus divided by 2 plus 3s cubed minus 2s will give us minus 2s cubed plus 3 times 3 is 9. 3 minus 1 is 2, so 9s squared. Then derivative of minus 2s will give us minus 2. Next, we have the y equal to 3x squared minus s plus 1 divided by x. First of all, we can, sometimes when we have an equation, if it's possible, we can reduce the equation. So for example, here we decided to divide 3x squared by x minus s by x and 1 by x, and that gives us 3x minus 1 plus 1 over x. Now we can find the derivative of each term. So the derivative of 3x will give us 3. Now the derivative of minus 1 is a constant value, so that will give us 0. Now derivative of 1 over x, we will get x to the power negative 1. So it will give us negative 1 times x to the power negative 2. So that's what to the power negative s to the power negative 2 is the same as writing 1 over x squared. Then if we like, we can combine the answers. So we can find the LCM to be s squared. 3 times s squared will give us 3s squared, then minus 1. So next we go to the derivative of sine and cosine functions. Now, derivative of sine x is cos x, and also derivative of cos x is equal to minus sine x. So this is a two important rules we should know when we are dealing with trigonometry functions or sine and cosine functions. The derivative of sine x is always cos x. Derivative of cos x is always minus sine x. So let's see an example here. Y equal to 2 sine x. This is using constant multiply rule. So we leave the 2 alone. Then we find the derivative of sine x, which will give us cos x. So the answer will be 2 cos x. Next example, we have y equal to sine x divided by 2. Now, since 2 is a constant value, we can bring it out first. So we get half times sine x. So half, we leave it. Again, derivative of sine x will give us cos x. So our answer will be cos x divided by 2. Next, we have y equal to s plus cos x. Now we need to find, this is a sum rule. So we need to find the derivative of x, then we need to find the derivative of cos x. So derivative of x will give us 1 because the coefficient is 1 and it will raise to the power 1 minus 1, which is 0. S to the power 0 is 1. 1 times 1 is 1. Then we know the derivative of cos x is minus sine x. So the positive sign changed to negative. Next, we have y equal to cos x minus pi over 3 sine x. Again, pi over 3 is a constant value. So here we can use the difference rule. We find the derivative of cos x, which will give us minus sine x. Then we have minus pi over 3. We leave the constant value. Then we find the derivative of sine x, which will give us cos x. So again, derivative of cos x will give us minus sine x. Then the constant value, we leave it alone. Then derivative of sine x will give us cos x. Next is the derivative of exponential functions. Now we also have a special rule here, which says that the derivative of a natural exponential function is the same value. We can prove it by using the limiting rule. So again, if f at s equal to e to the power s, the derivative of e to the power x is e to the power x, which is here. So let's see an example. So find the derivative of each function. First, we have 3e to the power x. So the answer will be the same. We leave the constant value. Derivative of e to the power x is the same as e to the power x. So the answer will give us the same 3ex. Again, to find the derivative of a function 3e to the power s, we have constant value 3. Derivative of ex is the same as ex. Now let's look at the second one. We are looking for derivative of s squared plus ex. Now derivative of s squared will give us 2x. Derivative of es will give us es. So the answer will be 2x plus ex. And that's what we have here, 2s plus es. Again, derivative of s squared is 2x. Derivative of ex is ex. Next, we have the f at s equal to sine x minus ex. So to find the derivative of sine x, that will give us cos x. To find the derivative of es will also give us the same ex. So our solution will be cos x minus e to the power x. So that will be the conclusion of these lectures. So again, these lectures will learn how to use the sum difference rules, the derivative rule for sum and difference. And also we learn how to find the derivative of a cosine, sine, and also exponential functions. Again, thank you and see you in the next lectures.